Hey everybody, today we're going to start Target D. Okay. And Target D is all about graphing our own rational functions. Before we can graph rational functions, we need to be able to find the specific key things of rational functions. That includes horizontal asymptotes, and then vertical asymptotes, and those holes that we've been talking about. Okay. So, some vocabulary. The first thing we have, really our only vocabulary word that's new is, we call them points of discontinuity. Okay, so again, it's the point in a graph where the function does not connect. A rational function has points of discontinuity at vertical asymptotes and at poles. So again, our vertical asymptote is a vertical line that corresponds to the zeros of the denominator. A hole in the graph that occurs at a common zero of the numerator and denominator. Okay, so in a little bit, we're going to go into a little bit more depth about when a vertical asymptote occurs and when a hole occurs. But right now, we are going to look at identifying horizontal asymptotes from the degree of the numerator and the degree of the denominator. Okay? So if I want to know what type of horizontal asymptote, or where the horizontal asymptote of a function is going to be, there are three cases. The first case is the numerator, right? The degree of the numerator is greater than the degree of the denominator. Remember, your degree is the exponent. So, degree means exponent. There is actually a typo here. I took the wrong direction. This one should be if the degree of my numerator is less than, so this should be less than. So please make that change in your own notes so that you can refer back to it. The degree of my numerator is less than the degree of my denominator, then y equals 0. Okay. That's case 1. Case 2, if the degree of my numerator equals the degree of my denominator, then y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. Okay. We'll go into what that means. And then, if the degree of the numerator, this one's also backwards, right? This should be greater than. If the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. Those are our three cases. Yes, you will have to memorize those three cases. Okay? Alright, so let's look at A. F of x equals 1 over 3x squared plus 3x minus 1. The degree of my numerator would be equals, right? There's no variable here, so my degree is 0. The degree of my denominator is, right, the highest exponent is 2. So, 0 is less than 2, right? So, that falls under case 1, right? If the degree of my numerator is less than the degree of my denominator, y equals 0. So this falls under case 1, y equals 0. Alright, looking at B, calculating my exponent on this x is a 1. Same thing here, I have a 1. So 1 equals 1. This is the one where my numerator and my denominator are equal. When my numerator and denominator are equal, it's the leading coefficient divided by the leading coefficient. It's still y equals. Okay? So here I'm going to have y equals, well, my coefficient in front of this is 1, my coefficient in front of here is 1. I only care about the leading coefficient. So 1 divided by 1, y equals 1. This is case 2. All right, letter C. My degree here, right, my highest exponent is 3. My degree here is 2. 3 is greater than 2. Again, looking at the three cases I have here, if the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. Right, so this is case 3. So, none. Easy enough. Alright, and then finally, D. The degree of my numerator is 2. The degree of my denominator is also 2. 2 equals 2. This is our second case when they are equal. So all I care about is the coefficients in front. This one is 1, this one's -4. Y equals 1 over -4. So y equals, anytime you have a negative, a positive divided by a negative is a negative. So I just pull it out front. Y equals -1/4 is my thing there. Okay? So those are the 3 cases. Again, you do have to memorize them. The easiest way to memorize them is just practice, 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 practice. Alright, the next thing we're going to look at, yours moves on to the next page. The thing I have up on my OneNote for some reason is split. So go ahead and turn the page. This, for our second example, I'm going to find any vertical asymptotes or poles. Okay? There's 3 steps, I believe. The first step is just like anytime we've been simplifying or doing any of that in our last target. You want to completely factor the numerator and denominator. Okay? Set any common factors between the numerator or denominator equal to 0. Those are going to be your wholes. So if I cross something out in both the numerator and the denominator, that gives me a whole. I get vertical asymptotes from any remaining factors in the denominator. Right? Those are where your vertical asymptotes come in. So let's look at some examples. For our first one, right? Let's start by factoring. 4 is a factor, x squared minus 3x. That has the greatest common factor of x. And that's just x minus 3, and I take that out. So I'm going to look for wholes. Nothing cancels, so there's none. I'm going to look for vertical asymptotes. Any factor I have in my denominator I'm going to set equal to 0. So x equals 0. And then when x minus 3 is a factor, x equals 3 is my 0. Right? So it's that same thing, switching between zeros and factors. And that's it. We're finding wholes and vertical asymptotes. Alright, looking at B. Again, I want to completely factor. So I'm going to start, the top is difference of squares. So I have x minus 3, x plus 3. Right? I need both the minus and the plus version when it's difference of squares. Then my bottom, the first thing I'm going to notice is that there's a greatest common factor of 3. A lot of us are still forgetting to pull out our greatest common factor. I know it's a trinomial. You still have to pull out your greatest common factor first. So I'm going to pull out that 3. I'm left with x squared minus 2x minus 3. Right? Now that I've pulled out my greatest common factor, now I'm going to factor that remaining trinomial. So what multiplies to -3, but adds to -2, that would be -3 and 1. Right? So x minus 3 and x plus 1. So yeah, the first thing I want to look for is wholes. Wholes are where you cancel factors out. I can cancel an x minus 3 out of both of these. That's a common factor. If x minus 3 is my factor, then x equals 3 is the whole. And that's it. That's the only thing I canceled out. Then for my vertical asymptote. If it's just a number, it can't do anything. 3 can't equal 0, no matter how hard I try. 3 will not equal 0. X plus 1 can equal 0 when I switch it, right? If x equals -1. So that's the only one that matters. Only if there's an x in it can you find a vertical asymptote. So that 3 is just an extra 3. Okay? Alright, looking at our next example. I have x plus 2 over 2x plus 6. That's x plus 2 over, I'm going to pull out the 2, x plus 3. Starting with wholes. I can't cancel out any factors, so there's none. Looking at vertical asymptotes. Right? Again, 2 is just a number, it doesn't count. So I have x plus 3. Switch the sign, x equals negative 3. Right? If x plus 3 is my factor, x equals negative 3 is my 0. Alright, looking at D, finally, our last one. I'm going to start by factoring, right? If I look, 2x squared plus 10x plus 12, that has the greatest common factor of 2. For on one, I'm just going to start by factoring the trinomial, so that's x plus 2, x plus 1. Okay. Now, again, I need to factor the trinomial on top. 2 times, that's x plus 2, x plus 3, right? 2 times 3 is 6, 2 plus 3 is 5, all over x plus 2, x plus 1. So from here, I want to look, do I have wholes, do I have vertical asymptotes? So again, wholes come from what you cancel out, right? You're creating a gap. I can cancel out these x plus 2. So as x plus 2 is my factor, x equals negative 2 is my 0. My vertical asymptote. Right? Again, I only care about the denominator for my vertical asymptote, so x plus 1. If x plus 1 is my factor, x equals negative 1 is my 0. So I have a whole at x equals 2, and I have a vertical asymptote at x equals negative 1. Alright, and that is it for the beginning of Target B. I will see you guys tomorrow. Have a wonderful evening.